Good morning, class. So in our last video, we had started with our passive devices, and the two types of passive devices, the connectors and the attenuators, we have already seen. As I have told, in the next video we'll start with the phase shifter. So there are different types of phase shifter. The phase shifters are nothing but the one through which we can attain phase shifts. If I need a particular amount of phase shift, if it is something like a 45 degree of phase shift, or if I need some 90 degree of phase shift or something like that, we can use phase shifters. There are different types of phase shifter. The main type of phase shifter is a precision phase shifter. As we had seen precision attenuator, in a similar way we have precision phase shifter. Yeah. So whenever it is a precision attenuator or a precision phase shifter, the diagram looks similar. This is the diagram you can use, which I had tried to draw here. It's not that neat. Two rectangular waveguides on both the ends, and middle it should be a coaxial one or a circular waveguide, I can say. So here what happens, as I have told, in case of attenuator we used three resistive plates, right? In a similar way, here we are using three dielectric plates, and there should be it should be placed in some position, right? So what is that position that we are placing these plates? And the lengths of the plates are considered as, this is of length lambda by 4, the middle plate is of length lambda by 2, and the last plate is of length lambda by 4. Again, as we had seen in our previous classes, there will be different transitions. Here it is RC1, rectangular to circular transition. Here it will be RC2, rectangular to again circular transition. So this end I can say it is our port 1, and this will be our port 2. Okay, and the lengths are L by 4, L by 2, and lambda by 4. In turn, this will consider it as length L. This we will get it as 2 times L, and this we will get it as a single time L. So here actually why we are considering it as lambda by 4, lambda by 2, and lambda by 4 is this will give a phase shift of 90 degree, and if this gives a phase shift of 90 degree, that means this should give a phase shift of 180 degree, right? So with this we can attain a phase shift of, or a phase constant, whatever we are considering, that should be 180 degree, and this will be 90 degree. This is actually the aim. That's why we are considering those lengths. If you want, I can say it is, we know that the phase constant is given by beta. I am considering it as beta L. We'll consider it for the first place. If it is beta L, what is beta? Beta is nothing but 2 pi by lambda, right? And L is nothing but lambda by 4. Fine. So what happens? 1 time, 2 times, lambda get cancelled. What remains is pi by 2. So if I need a phase shift of lambda by 2, that is 90 degree, then I have to use a plate that is of So the position of these plates, the dielectric plates, are, this makes an angle of 45 degree, and even this makes an angle of 45 degree. This is kept in such a way that it makes an angle of theta. How it makes an angle of theta, that we'll see now. So we'll consider the first thing, the first plate we'll consider like this, and it makes an angle of 45 degree, the first plate. Yeah. So So the first plate makes an angle of 45 degree. We'll consider it like this. Okay. Now we have to write the expressions here one by one. So first, initially, let us imagine the wave is traveling like this, as I have explained in case of our precision attenuator. In the same way, let us consider our first, this input signal is traveling in this direction. So the input signal, I'll consider it like this. This is our input signal. So this, let it be EI. Let it be EI. Now what happens? Due to the plate, I have to consider the components over here. The components of this signal can be splitted into two. One is which makes an angle of cos theta. As I have told, this makes an angle of 45 degree here. So what happens is the splitted signals will consider, one is this component, the other one is a perpendicular component, which can be considered like this. So this is our E1, I will consider, and let this be E2. Our EI makes an angle of 45 degree because our first plate is making an angle of 45 degree with the horizontal line or the vertical line, whatever it is. You can consider it in that way. So here what happens? The EI is split into two components. One is E1, the other one is E2. Now we'll write the expressions for E1 and E2. E1 can be written as it is EI cos 45 e to the power j minus j beta 1 L. Fine. So the first one making a phase shift of the phase constant, I can consider it as beta 1 L. So from this, what equation I can write is, it is, if I simplify this, cos 45 is root 2, 1 by root 2. So I can write it as EI divided by root 2 into e to the power minus j beta 1 L. Fine. This is also equal to, I will consider it as E naught e to the power minus j beta 1 L. Fine. Yeah, so this, let this be our equation number 1. Now, in a similar way, what will be our E2 equation? E2 will be equal to, it is, E2 will be equal to, it's EI sin 45 with an angle e to the power minus j beta 2 L. Okay, what is the phase constant for that wave in that direction? It is beta 2. First one I am representing it as beta 1, the second one I am representing it as beta 2. It is the same for the continuing signals also. So here what expression I can write from this? Again, sin 45 is nothing but 1 by root 2. So this can also be written as EI divided by root 2, it is e to the power minus j beta 2L is the expression. Now this can also be written as it is E naught e to the power minus j beta 2L. Now we know that the phase constant of this and this, in total I can say the phase angle between them is 90 degree, right? Because these two makes an angle of 45 degree here, 90 degree here. So what expression I can write? I can say beta 1L minus beta 2L is equal to 90 degree or pi by 2, whatever it is, pi by 2 or 90 degree. That means I have to represent beta 2L in terms of beta 1L. So can I write beta 2L is equal to beta 2L is equal to beta 1L minus pi by 2. Yes, let us substitute that here in the expression. So this equation can be written as E naught e to the power minus j beta 2L is nothing but our beta 1L minus pi by 2. So if I split this, I can write it as E naught e to the power j pi by 2 as one term, another term is e to the power minus j beta 1L. Now this can be written as, what is e to the power j pi by 2? E to the power j pi by 2, we know that e to the power j theta is, it's cos theta plus j sine theta, right? In a similar way, if I substitute in place of theta it is pi by 2, then cos pi by 2 is 0, j sine pi by 2, sine pi by 2 is 1, so what remains is j. So this can be written as j e naught e to the power minus j beta 1 L. Now what is our equation number 1? Our equation number 1 is e naught e to the power minus j beta 1 L. So can I replace this with e1? So this equation is equal to j into e1. This I can name it as equation number 2. Guys, understand the derivation carefully, because only the first and some second equation I will derive. Rest everything, rest derivations you have to do. You have to complete the derivation. Yeah. So our first part is done. The first signal, the input signal was ei. That input signal, what happened when it was the input signal, we had given that input signal over here ei. It reached the first dielectric plate. It was making an angle of 45 degree with the plate. So when it was making a 45 degree with the plate, I have to consider the components which is going to the next plate. It is not like our attenuator. In case of attenuator, it was a resistive plate and only the perpendicular component was moving further and the parallel component was absorbed by this. But here it is not that. Here both the signals are moving front. So what happens, these two signals, so the splitted signals E1 and E2 are going to the next plate. So when it reaches the next plate, as I have told, the next plate is making an angle of theta, right? So we can draw it like this. The next plate I will consider. Okay, so the next, let it be like this. And we'll consider the plate. You just consider it you just imagine it properly. It's not that easy to draw the diagrams of these. So we'll consider this is our second plate, dielectric plate of length lambda by 2. Okay, now where our signals, our electric fields were in the direction, here was E2, one second, so it was E1 and E2, right? E1 was here, E1 was like this, we want to cross check, and E2 was perpendicular to this. Yeah, we can show it somewhere here. This was E2 and this was E1, right? See the diagram, E1 and E2. Yeah. Now, so as I have told, this makes an angle of theta, right? So this is making an angle of theta. Again, what I have to do, I have to split this E1 to 2 components, as well as I have to split this E2 to 2 components. There are 2 fields in 2 directions. I have to split each field so that I will get totally 4 fields, I can say. So here, the fields when I split, what happens is, see the diagram carefully. I'm going to split these signals. So if I split E1, the cos component will be here, that is, I will name it as E3, and the sine component of E1 will be the sine component I can show here, because our E3, the sine component and cos component should be making an angle of 90 degree, right? So I can show it here. I will name it as E4. Oh, yeah. So our first one is done, E1 and E1 got split into 2, E3 and E4. In the same way, I will split E2. The two components of E2 are one should be the cos component, then the other one should be, these two are making an angle, the orange fields are making an angle of 90 degree. E3 and E4 are also making an angle of 90 degree. So can I say even this angle is also theta? If this angle is theta, I can say the cos component of E2 is along E4. The cos component of E2 is also along E4, as well as the sine component of E2. The sine component of E2 is here. The sine component of E2 is here. I hope you all understood. E1 got split into 2, that is E3 and E4, that's cos and the sine component. In a similar way, E2 got split into 2, that is the cos component as well as the sine component. The cos component is here, the sine component is here. Now seeing this, we have to write the equations. The simplification of E3 I will do, E4 and so on, you have to do it your own. So we'll write the equations. So what I can say from here, I'm getting two equations. One is E3. So now how to write E3? E3 is the cos component of E1. So it is E1 cos theta minus or plus. We'll see that. And what is E3? For E3, which is the other field in E3 line, that is this in the opposite direction of E3. So this is the sine component of E2. In total the resultant field is our E3. I hope you understood. The resultant field is our E3. So how can I write E3? The resultant field E3 is E1 cos component and minus E2 sine component, E2 sine theta. Now what about the phase constant I have to consider? It is e to the power minus j. For the first one I am considering it as beta 1L. For the second one it is always beta 2L. Fine. So I have taken it as beta 1L. Now we'll do the simplification of this. Then we'll go to the next equation. So what simplification I can do here? We know what is E2. E2 is nothing but J into E1. Here your aim is, what you have to do is, you have to simplify the equation so that your final expression, it can be E3, E4 or whatever it is, it should be represented in terms of E0 and beta 1L. All those terms should be that. There might be some extra few terms, theta and pi by 2 and all. That's fine, but it should be mainly written in terms of E0 and beta 1L form. So here what happens, what simplification I can write? From equation number 2, I can substitute, this becomes E1 cos theta minus E2 is nothing but J into E1 sin theta into e to the power minus j beta 1L. Now from this I can take E1 outside. If I take E1 outside, what remains is cos theta minus j sin theta into e to the power minus j beta 1L. Fine. Now this can be written as E1 as it is, cos theta minus j sin theta is e to the power minus j theta e to the power minus j beta 1L. Fine. Upon further simplification, what is our E1? E1 is nothing but, I had written an expression here. E1 is equation number 1. E1 is E0 e to the power minus j beta 1L. So here what happens? I can write it as it's E0 e to the power minus j beta 1L. I have done a small mistake, minus j theta e to the power minus j, it's 2 beta 1. Why it is 2 beta 1? I have to consider 2 times, right? Because the plate length is, if the first plate is of length L, then the second plate is of length 2L. So don't miss that. This is usually a mistake that we do. Consider it as 2 times beta 1L. Okay, so upon further simplification I can write it as it's E naught e to the power minus j theta e to the power minus j 3 beta 1 L. So we wrote the expressions in terms of E naught e to the then e to the power any number of times j beta 1 L. So this I will consider it as equation number 3. Equation number 3. Now in a similar way, what expression for E4 I can write? The simplification you have to do, E4 can be written as E4 is this component, right? Which are the components are here? E1 sine component and E2 cos component. So it is E2 cos theta plus, both are in the same direction, so I have to add them, right? So it is E1 sine theta into e to the power minus j 2 times, don't forget, beta 2L. For the first term, it's beta 1, the phase shift we are considering. For the second, we are considering it as beta 2. And in the previous case, it was only beta 2L and beta 1L and beta 2L. Here it is 2 times, as since the length is double that of the first one. So here what happens, what simplification I will just start, you have to complete it. So here again E2 should be written as, what is our E2? It is j into E1 cos theta plus E1 sin theta, then e to the power minus j 2 beta 2 L. Now what further simplification I have to do? The simplification I'll be taking E1 outside. If I take E1 outside, this is not in a standard form. Standard form is cos theta plus or minus j sin theta, right? So here j is multiplied with cos. So what I do, I will take even j also outside. If I take j outside, what do you get? It is cos theta, it becomes minus j sin theta e to the power minus j 2 beta 2 L. Yeah. Now further simplification, as I had told previously, you have to do, what all simplification you have to do is, you have to simplify this, then beta 2L should be replaced by pi by 2, it's beta 1L minus pi by 2. That substitution you have to do, because we want our final expression to be in terms of beta 1L, right? So if you do that simplification, you end in an expression, and that equation is E4 will be equal to, you will get it as E naught e to the power minus j theta, then e to the power minus j 3 beta 1 L e to the power plus j 3 pi by 2. You will get this equation. You can name this equation as equation number 4. Fine. Again, next what I have to do, I have reached the center. Next I have to go to the next plate. So if I go to the next plate, if I pass the signal to the next plate, plate makes an angle of 45 degree, right? So the next plate makes an angle of 45 degree. So we'll draw the plate. I will consider it here. Makes an angle of 45 degree. Where our E3 and E4 are there. So E3 is here. The color we used for E3 and E4 is this. So E3 is here and E4 making an angle of 90 degree, right? So E4 is here. Just imagine it's in a proper way. This is E3 and E4. Now what I have to do? I have to split it again, right? So if I split it, what happens? E3 cos and E3 sin. So where do I get E3 cos? E3 cos I can show here, and E3 sin I can show here. Next, in a similar way, what about E4? E4 I can show. Where do I get E4? E4 cos I can show it somewhere here. somewhere here, and E4 sine I can show here. So here the splitting of this E3 cos is here and E3 sine is here. For E4 cos will be here and E4 sine will be here, because with this it should make an angle of 90 degree, right? So the 90 degree will be here. With this should make an angle of 90 degree. So this in total will be 180 degree. So this is actually our E5 and this will be our E6. So what equation for E5 I can write? E5 is equal to cos component of E3 and sine component of E4 got added here in E5 because both are in the same direction. So it is E3 cos theta plus E4 sine theta into e to the power minus j beta 1 L. Again the length of the plate is 1. So what will be our E6? E6 will be, it is opposite direction. So E6 has which component? Cos E4 cos theta minus E3 sin theta into e to the power minus j beta 2L. Now you have to substitute for E3 and E4, which you have got it from your previous equation number 3 and 4. Upon those substitutions and simplification, you will end up with the equation that is E5 is equal to E naught e to the power minus j2 theta e to the power minus j4 beta 1L, and E6 is equal to, it's E naught e to the power minus j2 theta e to the power minus j4 beta 1L. So the resultant, so we have reached E5 and E6 means it is from our last dielectric plate. Now it is directly our output what we are going to get. So our resultant output what we are going to get can be written as, which is coming out from the other end, can be written as E out, which is equal to, how to write this? It is like, if I have two fields, one is like this and one is in this direction, this is our E5 and this is our E6. If I represent, the resultant will be like this, and this resultant field is given by it is magnitude. We are speaking about the magnitude, so it is the square root of E5 square plus E6 square. So these two terms are same, so it is something like the square, you are taking it outside. So can I write it as root 2, it's E naught e to the power minus j 2 theta e to the power minus j 4 beta 1L. Fine. You just imagine if this is e to the power j theta and if this is e to the power j theta, and if you add square e to the power j 2 theta plus e to the power j 2 theta, addition of this is 2 times e to the power j 2 theta, square root of this is root 2 and root of this, right? Root of this is e to the power j theta. That is what I have written. The terms are same. One extra term you have to consider is e to the power j 2 theta. So what did we consider? So this can be written as E naught is nothing but EI by root 2. So I can write it as, we'll substitute here, you will get the expression as EI e to the power minus j2 theta e to the power minus j4 beta 1L. So we got this equation. What was our incident signal? Our incident signal was EI, right? And there were three plates. First and second plate had a length of LL and the middle one was 2L. So the total length is 4L. Agree? That's why we got it as 4 beta 1L. Fine. So that is done. So what we got initially, it was EI. Now we got an extra term with a phase shift of 2 theta. So the phase shift what we got here by rotating those plate is 2 theta. So the total phase shift, the phase change is given by, it's 2 theta plus 4 beta 1L. So by using phase shifter, it's been explained how we can get the different phase shifts. So depending upon the directions or the rotations of the plate, we can acquire different phase shifts. So that's it about the phase shifters. The derivation is very important. Usually this question is asked. But here you have an assignment. What you have to do is you have to complete the derivation. You have to complete the derivation, the intermediate steps of all the simplification things I have not given, which you have to do it your own, and you have to get those equations. Okay guys, thank you.